Hello friends, this is my starting first YouTube video. In this video, I am going to start a new channel where I will be talking about a lot of coding problems with ease. The channel name is in fact Coding Problem with Ease. Here I will talk about coding problems, different coding algorithmic problems that are usually asked in interviews, and they are all across different websites like Gigs for Gigs, LeetCode, HackerRank, Google Code Jam, and Topcoder, and so many other websites. In this complete tutorial series, I will cover trees, hash maps, graphs, stack and queues, linked list, dynamic programming, tries, and Huffman coding, and so many other different programming concepts. And the biggest factor is that this particular tutorial series will mostly be practical coding, which means I am not going to talk about all the theories without showing you any particular problem that actually uses those concepts. So let us get started with the first problem. So this is the first problem that we have. We are given an integer array, and in that integer array, we needed to find maximum consecutive sequence in the array whose sum is 0, which means you need to find out what is the longest subsequence of this array which are consecutive and whose sum will be 0. For example, if you add 6, 3, minus 1, 2 and minus 4, you will get 0. So 6, 3, minus 1, 2, minus 4 is one subsequence, right? Is one such subsequence. And the subsequence needs to be consecutive and their sum needs to be 0. This is the problem that is given to us. What is the usual approach? What is the brute force approach that we can use to solve the problem? Well, we can find all the consecutive subsequences that are possible in this array. For example, you take 6 and then you do 6, 3, 6, 3, 1, 6, 3, 2, 6, 3, 4, 6, 3, minus 1, 2, minus 4, 6, 3, minus 1, 2, minus 4, 3. You take all the possible subsequences of 6. Then again you do 3 and minus 1, 3 and 2, 3, minus 1, 2, minus 4, all the subsequences of 3 and so on. And then you find after finding all the subsequences, what you can do is you can figure out which of them are actually summing up to be 0. And you can take those and filter out rest of them. Once you have done that, what you can do, you just simply need to check which one of those sequences are longest or maximum length. This is one way we can solve the problem, right? But obviously, what is the time complexity? The time complexity is, in this case, the worst possible is n square, because we are actually doing n square time to find all the consecutive subsequences. Then we are doing big O of n to actually calculate the sum of all the elements and all the subsequences who are giving sum as 0. And then we are doing another big O of n task to find out which one of them is actually longest. So the total time complexity is big O of n plus big O of n square plus big O of n, or maybe 2 big O of n you can write, right? So the time complexity will be actually big O of n, or order of n square, because that is the most dominant part. Now the question is, can we do better? Can we just bring down the complexity? Let's see. So it is very clear that we cannot solve the problem using a normal approach. Now, before I move ahead and with a solution, pause the video and think about a solution. You don't have to code, you don't have to find out anything, just think about a solution, and then if you cannot solve, then resume back and watch it. Right. Hopefully you have given a proper thought. Now let us see what are the things that we can do. Okay. So imagine that you have an array like this, right? You have an array like this. In this array, let's say there is an arbitrary position, which is the ith position, and there is another arbitrary position, which is the jth position, right? This is the array. The total size of the array, the length of the array is n. Now, the sum of all the elements from the very beginning to the ith position is, let's say, S1. Sum of all the elements from the very beginning to the end element is S2. Now, let's say that S1 is X, S2 is Y. Before I move ahead, let me tell you some constraints. The constraint is n should be obviously greater than equal to I and j, and I should be less than equal to j. If you have this kind of scenario, you have S1 and you have S2, right? S1 being again sum of all the consecutive numbers, sum of all the numbers from 0 to ith location. This is the cumulative sum, by the way. And S2 is basically from 0 to jth location, sum of all the numbers. This is also a cumulative sum. What will happen if S1 is equal to S2? If S1 is equal to S2, that means we are basically saying that till this part, the sum is, let's say, X, and till this part also, the sum is X. That means in between, whatever numbers we have added, that had no effect, that had basically no effect on the cumulative sum. This is basically no effect on the cumulative sum. That means I can say that in the array from the ith location to the jth location, there is a subsequence which can be added up to 0. So this is the actual hack we will use to solve the problem. Now I would ask you to again pause the video, and as you have already understood the actual way that we will solve the problem, try to think in the coding perspective. We will use any language like C, C++ or Java. In our case, we will use C++, but you can use C++, C, or Java, or even Python also. You can use any of the programming language to code this up. Now that you have understood the algorithm, think about any one of the programming language that is comfortable for you, and think about the solution, how you would approach the problem in code. Okay, I hope that you have given a proper thought. If you haven't, don't worry, I'll explain to you how to solve the problem. Let's say that you have this array. So what we will do is we will create a data structure called hash map. Now hash map is already present in C++. It is also present in Java. It is present in, I guess, Python. You call it dictionary. Unfortunately, it is not there out of the box in C, but you can always implement an hash map on your own. Okay, I will be using C++. So in C++, it is available in unordered map, or you can also use it in a simple map. So this is basically using hash tables. This is basically using a BST. But this is a bit faster than map. However, this is much more stable than hash tables. Okay, so let us understand how we will solve it. We will use unordered map, by the way. So let's create a hash map of an integer and integer, right? And we will basically have two values. First is the cumulative sum, and the second is what is the first index that sum has occurred. I'll tell you slowly. Let's say we start from the first element, 6. What is the cumulative sum till now? Only 6, right? So I'll write 6, and the first index at which I got 6 is 0. I'll move this pointer to next element. I am now pointing at 3. What is the cumulative sum? 6 plus 3, 9. And my pointer is now at first position. Again, I'll move the pointer one step. Now 9 minus 1 is 8. 8. I am at second position. Again, I'll move the pointer one step. 8 plus 2 is 10. 10. I am at third position. Right? Again, I'll move my pointer to 4. 10 minus 4 is 6. Now this time, I can see that the element, the cumulative sum, was already present. I am at fourth position, by the way. My current I value is at 4. And whenever, at the moment I see what should be the value, 10 minus 4, because at fourth location, this is array, let's say, then ARR of I is basically minus 4. And I have 10 as a cumulative sum till now. So 10 minus 4 is 6. 10 minus 4 is 6. Right? I have 6 already present in the array, cumulative sum. Right? The moment I see an element or a cumulative sum which was already present in the array, I can tell you that at this location, the same sum is coming back again which came before. So that means cumulative sum came at location 0. Cumulative sum 6 is again coming at location 4. That means there is a possible subsequence whose sum can be 0 from 0 to 4. What is the number of element between 0 to 4? There are total 5 elements, right? There are total 5 elements. So initially, before starting the program, I would take a max length whose value is 0, and I will see if this value, the new length, is greater than this max length or not. If it is true, then I'll replace this max length with the new value. If it is not true, I'll keep it as it is and I'll move ahead. So now max length is 0, of course, so 5 is greater than 0. So I'll replace the max length with 5 and then I'll move ahead to the next point. Now, so here the sum was 6, so cumulative sum was 6, but I will not update this first index. So here I'm only interested to know about the first index. So the cumulative sum was 6. 6 plus 3, 9. Again another repetition. Again another repetition. So I can see that I am at this moment 5th location and the 9 came at first location. So 1 minus 5, right? So then if I see if 1 minus 5 is greater than the max length or not, if it is greater than the max length, I will replace the max length, or if it is not, I will not replace the max length. So how many elements were there? 1, 2, 3, 4, 5. Again 5 elements, right? 5 elements. If 5 is greater than 5, no, it is not. So I will not replace the max length. I'll keep it as it is and again I'll move forward. So now the cumulative sum is not 6 anymore, it has become 9. So 9 plus 1, 10. Again another repetition. So this repetition is coming from 10 is a third location and I am right now at this moment as at 6th location, right? So how many elements are there? 1, 2, 3, 4. Only 4 elements, right? Only 4 elements. Is it greater than 5? No. I will again not replace the max length. I'll again move ahead. And at this moment, my cumulative sum was 10. Now 10 minus 2 is 8. Again another repetition. So this time 2 was the last position where it was observed, and I am at this moment at 7th location. So how many elements? 1, 2, 3, 4, 5, 6. Now we see 6 elements. Yes, now it is more than the max. I'll replace the max with 6 and again I'll move ahead to this location. So last time my cumulative sum was 8. 8 plus 20 is 28. So 28 is a new entry, so it will go here, 28. And the 28 has occurred at which index? When I am at 8th index. And now I'll again move ahead and out of the array. So I'll end the execution of the program, and whatever the max length, I'll return. In this case, the max length was 6. Right? So the question is actually asking you to find out the max length. However, you can easily figure out what is the starting of the sequence and what is the ending of the sequence. It's very easy. Every time you are updating the max length, you can also update two more values like start and end. Start and end, you can also update these two values. But however, in this problem, we are only asking the max length. So both max length and start and end can be solved in big O of n time, because you are actually doing big O of n time to calculate the hash map values, this cumulative sum and the frequency values, and you are also at the same time figuring out all the possible occurrences of same cumulative sum multiple times. So this is how you actually solve the problem. Now again, I would like you to ask you to pause the video, think about any edge cases. Is there any edge cases in the problem? Well, I hope you have given it a proper thought. And yes, there are some edge cases in the problem. In fact, there is one edge case in this problem. Let us discuss what it is. Let's talk about this array, right? Now, beforehand, let me tell you what should be the maximum subarray in this problem. The maximum subarray in this problem is this, right? This is the maximum subarray. Now, let us see. You start with 6. So you 6, this is the cumulative, this is the table, same old drill, right? Cumulative sum, and this is the first occurrence or first index. So 6 is the cumulative sum and it occurred at 0th position. Then you move ahead, the cumulative sum is 7, it occurred at first position. Again you move ahead, the cumulative sum is 7 plus 5, 12, and it is the second position. Again you move ahead, 12 minus 8 is 4, which is at third position, right? Again you move ahead, 4 minus 4 is 0, and it is at fourth position. Wow, something wrong, because at this moment your sum should have been 6, because then only if your sum is 6, you would say okay, 6 already came, so the occurrence or the subsequence length will be 0 minus 4, which is the 5 values, 5 elements, right? 5 elements. But the sum is not coming out to be 0. Sum is coming out to be 0. Sum is not coming out to be 6 in this case. So which means this is the kind of edge cases. So the improvisation on the previous problem is that every time you are finding out the cumulative sum, in the previous case, right? In the previous case, whenever we are finding out the cumulative sum, we are blindly pushing that cumulative sum into the hash map and the first index at which it occurred. But this time we see that the improvisation is that you cannot blindly push the cumulative sum into the hash map. You also need to check if the cumulative sum has already become 0. So this is a sign, right? The cumulative sum has already become 0. That means till this point, whatever the cumulative sum was at the very beginning, till this point, the cumulative sum has become 0. That means from the very beginning to the end, this can be the subsequent length. So every time, so which means that we will only push a new number into the hash map if it is non-zero. If it is 0, that means from the beginning till the end, we have seen a particular number, we have seen a particular index where the total sum can be 0. So at this point of time, we will obviously update. So there is a max length variable which was 0. So we will obviously update. So we will do 0 minus the initial value was 0 and the current value was 4. So we will do 0 minus 4, 5 elements. So we will update 5 and we'll push 0 and then we will move ahead. Right? Then we will move ahead. We will move from 4th location to 5th location. And then we will see that 0 plus 2 is 2. 2 is not occurred anywhere in the cumulative sum. So 2, and there will be 5th location. and I am out of the array. So the maximum length is 5. So this is the edge case, guys. So in the next session, we will actually see how to code this algorithm up. So this whole tutorial series, I will be doing in alternate sessions of theory and code. So this is the theory of all this problem. In the next session, I will actually code this problem in C++ and I'll show you that this code actually works. Thank you.